This is the 2010 Higher Level Geologic Geometry question. For this question we are told that A to B is level at a height of 60 meters. Therefore, as you can see being created now, we need to create embankments because the contours are lower. For embankments, side slopes are 1 in 2. So therefore, between our contours is 5 meters. So on our map, it will be required to be 10 meters in order to find the earthworks required to complete this question. Further on, we can see that we require a cut. For cuts, we know embankments, cuts are 1 is to 1.5. Therefore, as we can see, our 65, our 70 and 75 meter planes are created and simply match them up to the points, to the contours, to create our earthworks. Finally, we are told that B to C is rising in a distance of 1 meter in every 30 meters. Therefore, for this question, we can draw out 240 meters, and because we know that we will be requiring an embankment for this question, it is 1 and 2, so therefore we will be rising 16 meters to create our arc for our cones, as can be seen in our 3D view. The road is rising. So our 60 meter line is really a level line, however on our plan it will appear as though it is at an angle to the roadway, but instead it is the roadway that is rising. Once again, for this part, we know it is an embankment, so our distance will be 10 meters between our 60 meter, 65 meter, and so on. For the second part of the question, we are told that E, F, and D are outcrop points on a stratum of ore. So, as you can see, our strike is already determined. That would be point E to G, and we are asked to determine our dip. So, we simply need to create an XY line or a ground line, which will be at 0, 0, and bring points D and F parallel to our strike, and simply mark off our heights of D, which is on the contour 55 meters, E, which is on 65 meters, and F, which is on 80 meters. Once we create this line, this will give us our dip, which is in relation to our X1, Y1 line, as can be seen in our 3D view. The next part of the question tells us that a vertical borehole at F reveals the bottom surface of the stratum at 25 meters. So in plan, a vertical borehole will appear as a point at F. So we need to find this distance of 25 meters. In order to do this, as you can see in our 2D view, we look along our strike line, or a line parallel to our strike, measure 25 meters and mark it on. We know that our head wall and our foot wall are parallel, so therefore we can create our foot wall as shown, and this will determine our thickness, which is a perpendicular line between our head wall and our foot wall of our stratums, as can be seen now in the 3D view. This view is looked in along our strike line. Finally, we can see our fully finished solution to this question.